Hi, I'm Alex Gee. I'm a product manager here at u-blox, and today I'll take you through how to use your evaluation kit for the ZX20P product line. The same evaluation kit is also used for the ZF20P with some additional configurations since the X20P is the big brother of the F20P. These products are commonly used in robotics, precision agriculture, and UAVs. The evaluation kit can be used in several modes. I'll show you how to use them, but first some background. When we talk about high precision GNSS, we're referring to something that's different from what you typically get in a smartphone. Smartphone GNSS accuracy is about 1.5 meters, whereas high precision GNSS like X20P can achieve centimeter level accuracy. This is made possible through special technology called correction services or augmentation services, which enable more accurate modeling of atmospheric conditions and other sources of errors at the satellite to refine signal measurements. If you are trying to build something that is a bit closer to the end application and need a programmable host processor or additional wireless interfaces that the evaluation kit does not have, I would recommend that you look at some of our partners such as ArduSimple, SparkFun, GNSS Store, and others. During this presentation, I'll be using a standard Windows PC with Windows 11 installed. On the PC, we have uCenter software installed as well. This is downloadable from the uCenter website. Note that the legacy version of uCenter is not supported for X20 products. I hear some grumblings about the need to provide an identity to use uCenter 2 on the online forums. I'll explain to you why this is needed, even though the policy might change in the future. uCenter is the single tool for all our customers ranging from amateur users to professional users. As such, there are advanced features that are only accessible to professional users. Using Salesforce registration, we are able to manage this. The other reason is to gather usage data so that we can improve the usability for frequently used messages in an efficient way. You'll need at least one EVK-X20P. If you plan to set up a base and rover configuration, you'll need two kits, one as a base and one as a rover. We also use PointPerfect, u-blox's line of correction services. In case you're not familiar with these services, I'll give you a quick plug for my services group. Essentially, today we offer two services, RTK and PPP RTK. RTK is the most accurate and fastest to converge, but tends to be more regional specific. PointPerfect Live has more restrictive service plans in terms of duration. PPP RTK, on the other hand, uses the Spartan protocol, which is an open standard. It is a bit less accurate. It depends on your application. PointPerfect Flex is more flexible with all kinds of plans, including pooled plans, where you can share the total time between multiple devices in a fleet. Finally, we have also announced PointPerfect Global, which is a PPP AR service planned for next year. The AR stands for Ambiguity Resolution. What I will show you today are how to update firmware in normal operating mode, set up a base and rover configuration, set up a rover using PointPerfect Flex PPP RTK service. Along the way, I'll also show you some tips and tricks with uCenter 2, since many users are less familiar if you are migrating from legacy uCenter. When you open the evaluation kit, you will find a thank you card, a 1-month trial subscription to PointPerfect Flex, the EVK itself, a USB cable to connect to the PC. Note that there is a technical issue that it can only connect to a USB-A port on a PC. This is being addressed in a future version. There's also the NMB antenna, all-band active antenna. There's a ground plane that you'll need to optimize performance when you're not using it on a metal surface like the roof of a car. And finally, there is a patch cable that you can connect to the front of the EVK so that you can connect it to systems like Raspberry Pi. At the time of this recording, the released firmware is HPG 2.00. I happen to have HPG 2.02, and I'll show you how to update it. The firmware update process conceptually has 4 stages. It starts in normal operating mode, then it enters safe boot by firmware command, and then it needs a training sequence for the UART. And then finally there is the actual firmware update. This all happens automatically. We connect the EVK to the PC and select UART 1. I have 2 EVKs connected, so there's 2 UART 1s, one from one EVK and one from the other. So 57 is UART 1. And we do autobaud. You can see the baud rate is 38,400 in normal operating mode. You can see the monver, which is the version of the software. You can see it's 2.00. And now I'll do the firmware update. Up here in the tools section, the firmware update. I will go to 2.02. And it's important to click the safe boot before update. And then we do an update. And it takes about a minute. The firmware update process is successful. And if you look at the baud rate, now it's at 38.4. And if I go click on the monver, you can see this gets updated, and it's 2.02 in the screenshot. It can happen that an update is unsuccessful because you lost power during the update process and you need to do an update from safe boot. The way you do this is you unplug the EVK and plug it back in. On the front panel of the EVK, you press both the safe boot button and the reset button. You release the reset button first, followed by the boot button, and then the device will be in safe boot. Unfortunately, the firmware update tool also needs another update. What happens is you need this training sequence, and I'll put it back to 2.00 just to. And what happens here is you get the there's a command line here that's shown at the bottom. What is missing is the option to enable the training sequence, which is this -T0 here. So if I copy this thing and I go to the terminal window, and if I paste the command line that I got from the uCenter into this command shell, not the PowerShell, but the command shell, and if you change it to so that the training sequence of 1 is here, that it sends the training sequence, and then on the right port, 57, then you can see an update happen on the command terminal. And it takes, again, a minute. Now it says firmware download complete, and then it's validating the firmware, and then it's done. So it takes about a minute. So now if I go back to uCenter and I open port 57, you see there's now 2 USB interfaces because I have 2 EVKs here. That means it's back in the normal mode, and I can do autobaud. And now it's working. Okay, now let's walk through how to configure a base and rover configuration using 2 evaluation kits in the uCenter software. We have it connected to In this case, I'm in the studio. I connect it to a rooftop antenna. I will change the baud rate to 460k baud. And so this is what you need to do. Otherwise, you can see the data rate's about 15k, but if you run the correction services, things will, or you send the corrections from one receiver to the other, you will overflow the buffer. So you need to update the rate. So I will do that right now. So what we do is over here is the configuration. And there's a filter here. If you type baud, you can see the baud rate, and it's at 38.4, and now we change it to 46800. And I'll set it into the flash layer. And then I will send it to the receiver. You see it's green. And I prefer doing it in the flash layer compared to the RAM, because when you do the RAM, right away it takes effect, but you don't really get the acknowledgement from the receiver. And so that's done now on one device. I will now go onto the second device, which is on 59. This is the other UART port. And you see it's there, and I do the same thing. The baud rate's already there, and now we're talking to the other receiver. You notice it's still at 38.4. So for 600, 800, I set it for flash again, and I press send. Now both receivers have written to flash, but they're not running at the new baud rate. So don't save. Now I will press the reset button on both receivers. And I will get rid of this, start a new port, and start UART 1, and I'll do auto baud. Now you can see it's searching. Notice that now the new baud rate is 460k baud. And I can see I can see the 2.0 that I flashed back onto the device. Next step is to do a survey in. Under device configuration, we have now a new feature here called quick configuration on the left here. And under time mode. And what you do here, you put survey in mode, minimum duration of 60 seconds, and an accuracy of, let's say, 5,000 millimeters. And we'll do this in RAM. And all I have to do is press send. This message has been sent successfully. And in the console, there is, if you go look at nav, survey in, and I'll enable the message. You can see it's constantly being updated here. And this timer is now at 30 seconds, and it's incrementing until it gets to 60 seconds, because that's what we did. That's a quick survey in, and a real application you would probably survey in for longer periods and to also a tighter accuracy. So let's get it to this, and notice that the valid is 0 here on the bottom, and when it gets to the 60 second, the valid will become, let's see what happens here. There, now the valid is set, so that the rover is now surveyed in. Next step is to set up the Ntrip server. So what you do is you click here and you set the Ntrip server. There's no IP address. It's running on whatever is on. I have it's on port 2101. I enabled authentication. The username is UBX. The password I've also set to UBX. I set everything to UBX. The mount point is UBX, and I put the country Switzerland. And then this is all good. You click all, and then you say start. Now you notice in the bottom right, it says something about number of successful configurations 10 out of 12. That's normal, don't worry about that. The reason for that is that a few of the messages have not been implemented yet for moving base, and that's why you have that, but that's okay. Now the server is running with no connections. Now I will start another copy of uCenter. Hope I can keep these two straight. Now we connect to 59, which is the base. We said this is the other one, and we connect it. And the baud rate settles down, everything's good. And now I'm going to put, you can see that it's got a 3D fix, so some points I'll point out to you here. uCenter needs to enable specific messages for the views to work. Otherwise, it's working on the enemy messages, and the quality of the data that you see on the screen is not as good. So typically, you would go and click this, and click this, and click this, so that the warnings will disappear. You see the warnings disappear. And this guy, you could have a map here, and you could also click here. So now there's the rooftop antenna at u-blox that I was telling you about. See, that's our office. And then, yeah, so you can see there's a 3D fix on the Rover. And then what I will now do is enable the Ntrip client. And what we said here, it's called, we said it's called, there's no IP address. Okay, it's run the local host, and then UBX. So you see there's a mount point. You select the mount point, and you see I'm receiving data from the other rover, and you can see that the fix is now fixed, and it's centimeter level. What I'll do here is I'll show you, I will flush the database, and here's the deviation map. And you can see this is 10 centimeters, this is 5 centimeters, and you can see that all the readings are super tight within the circle. See, all the points are all stacked up on this thing. There's some statistics that we're generating here. That's a feature here. You can show some statistics. You can see what the maximum deviation since we flushed the database. And of course, it's very, very tight. It's like, I don't know, 2 millimeters or something like this. Okay. I do have one point to add that for corporate users, most corporate PCs will be running some kind of firewall, and that will prevent you from running the Ntrip server. If you're suffering from this, you'll get some very strange behavior where the client tries to connect and it will be quickly disconnected by your firewall application. You need someone to add some rules from the IT department for this to work correctly. Okay, I will now disconnect this. Okay, this is okay. Yeah, I will disconnect from the Ntrip client. I will this is the base. I will close that off now. Okay, so that was the end of what I wanted to show with the base Rover. Now I'll show you how to set up the Spartan PPP RTK service over Ntrip. What there is, so from our services people, you will get you can get into an application on our ThinkStream portal. Under location services, and today what I will use here is this device called Alex Flex, and I have the credentials here. And in this case, these are the credentials that we'll be using. You can see the server name. I will go ahead and copy each of these things over to the Ntrip client. Okay, let me see if I can do this in a good way. Okay, so now this will be this, the port's 2101, UBX is, this is the username. You see there are a number of service mount points that you can use. I'm in Europe, I'm in Switzerland. One of the services that we have in Europe is called Near Spartan. It picks the closest stream nearby. I select that. You can see it's receiving correction services. And again, I will get this out of the way. You can see now it is fixed. And you see all your corrections. So I will flush the database again to show you how tight the set of points are. So you are getting some very small, very, very tight accuracy in this thing. And that's basically how easy it is to use PointPerfect PPP RTK service. In summary, I have shown you how to update firmware, run a base Rover configuration, and also access a PPP RTK service. I hope that you found this video helpful. We appreciate you using the ZX20P, our latest generation of high precision GNSS receiver.